Today's lesson is on mixed and entire radicals. So before we get started here, we're going to start talking about the parts of a radical. And in order to do that, we're going to do a little bit of a reminder here that this entire thing, whole thing, there's square root, the index, all of it is called a radical. Okay, so the entire thing is what we call a radical. The little n, this piece right here, little n there, it's called an index. So this is going to tell you whether you're taking a square root, a fourth root, a fifth root, a sixth root, whatever the number might be, it's what type of root you are taking. Everything underneath your square root sign is called a radicand. So if you come across those terms, you now know what they mean. Now we're going to start talking about the multiplication property of radicals. So when I have something that states I have the square root of two numbers that are multiplied together, I can separate that square root so that I am taking the square root of your first number and the square root of your second number, your third number, so on and so forth, separately. I can take the square root of every number that is being multiplied together separately. This becomes super important when we're trying to solve problems that don't necessarily have a full square root or cube root or fourth root, but they do have factors that have those roots. So we can solve and we can simplify radicals this way. So for example, number one, we're going to take 72. We're going to split it into two numbers that multiply to 72. For right now, we're just picking any two numbers that multiply to 72, so 8 and 9. So that means that the square root, I would now have the square root of 9 times 8, which I can then turn into the square root of 9 times the square root of 8. Now this here is not simplified, this is nothing, this is just showing you with numbers what the rule is talking about. All right, for these ones here, we are going to simplify each radical to its simplest form. So simplest form means that there's no square roots left, like that can be taken out unless you cannot take the square root of that number. So that will make sense in a few seconds here. So when we're talking about these ones, the first thing we're going to want to do is we want to take the number that's under the square root sign and we want to factor it down to its prime factors. So 63, I have 7 times 9, and then 9 is 3 times 3. So I used a factor tree to find out all of my prime factors. You must have it in prime factors. It'll make your life way easier going forward. So now that I have my prime factors, I have the square root of 7 times 3 times 3. I'm going to now take these here and I'm going to group them. The number in my index is going to tell me how many numbers of the same number are going to be grouped together. So in this case, I don't have a number, which means it's going to be 2. So I can group my 3's together in groups of 2, and my 7 is going to have to be left by itself. It doesn't have a partner, and that's okay. So now I have the square root of 3 times 3 times the square root of 7. And the reason I kept my groups of 3 together are I know that that becomes a perfect square because it's the same number times itself. So that gives me the square root of 9 times the square root of 7, which is going to give me 3 times the square root of 7, or 3 root 7. You do not necessarily need to do this step right here. You can go and you can cross this step out and ignore it if you choose to, and go right from right here, where you have the square root of 3 times 3. If you know that that means you're just going to pull a 3 out of that one, that's fine. Just write down the 3 and leave your root 7. So our final answer in this case is going to be 3 root 7 or 3 times the square root of 7. Either one is acceptable. For number B here, square root of 80, I have 2 times 2 times 2 times 2 times 5 as my square roots here, or my prime factors, I should say. That gives me, I'm going to put them all underneath the square root sign. I'm going to group them in groups of 2. So these 2 can go together. These 2 can go together. And then the 5 is kind of left on its own. And that's okay. So now I'm going to take this and I have the square root of 2 times 2 times the square root of 2 times 2 times the square root of 5. Once again, you can skip this step here if you choose to, or you can multiply them together to just take the square root of them anyway. So you can go from here down to this step if you choose, or if it makes sense to you to multiply those two numbers together and then take the square root, feel free to do it that way as well. I am now got 4 times the square root of 4 times the square root of 4 times the square root of 5, which gives me 2 times root 5. That's going to give me 4 root 5, or 4 times the square root of 5, making this number right here my final answer. Now, I know I said when we simplify, we don't want to have square roots or anything like that. We don't want to have square roots that can be simplified. So root 7 and root 5, you can't actually take the square root of those without getting a decimal number. If you can only get a decimal number, you leave it under a square root sign. It is now in simplest form. All right, let's do a couple more examples here. The cube root of 108 means I'm going to take 108. I'm going to put it in its prime factors, 3 times 3 times 2 times 3 times 2. I'm going to put those underneath the cube root sign. And now instead of grouping in groups of 2, I'm going to group in groups of 3. So I have 3 3s. I only have 2 2s. That's okay. We'll deal with the groups of 3 first. So now I have this cube root of 3 times 3 times 3 times the cube root of 2 times 2. Once again, you can skip this step right here if you're choosing to, and you can go right to the last step, which is 3 cube root of 4. Right in this middle step here, all I did was take my 3's, multiply them together to get 27, multiply my 2's together to get 4. If I type in the cube root of 27 in my calculator, I am going to get 3, which is why you can skip this step and just pull out one of your 3's, because you've been told by your index that one of those 3's is going to be pulled out because it is a cube root. So we are left with the cube root, or the cube root of 4 times 3. This is your final answer. Now, when we're dealing with the fourth root, we're going to make groups of 4. So once again, we do have to put it into our prime factors, 2 times 2 times 2 times 2 times 2 times 2 times 2, all underneath the fourth root sign. Make groups of 4, one group of 4, another group of 4. I have an extra 2 here for some reason, so we're going to cross out that extra 2 because we don't actually need it. This guy here is not existent. I have an extra 1 for some reason. I should only have 7. Now, what we're going to do is separate those. So I have 4 2's under this square root, 4 2's under this fourth root. I now have 16 and 8 under my roots, which is going to give me the fourth root of 16 is 4. Fourth root of 8 is going to stay as the fourth root of 8. Once again, you can skip this step right here if you're so wanting to. Right here, this one, because it's not actually necessary unless it's easier for you to follow that way. So this gives me an answer of 4 times the fourth root of 8. Here we go, entire radical. So an entire radical is in the form of n root x. So an example would be square root of 100, the cube root of 80. These are entire radicals. Mixed radicals have a different form where they have a coefficient number in the front of it. So an a to n root x. So this part of this radical is going to be in simplest form. So that you must not be able to take the square root, the fourth root, the cube root of whatever number is underneath of it. So an example would be 2 root 10, 3 root 3, and the fourth root of 15. Those are all examples of mixed radicals. Example number 1 here gives me, write each mixed radical as an entire radical. So the steps to doing this are determine what your index is. So in this case, my index is going to be 2. And the reason my index is going to be 2 is that there is no number there. So if there's no number, it means your index is 2. This tells us how many factors of this front number, the number in front of it, this one right here, the 7, are going to be put underneath the radical and multiplied together. So I now know that I have an index of 2. 7 is my coefficient I'm dealing with. So I'm going to put 2 7's underneath this radical sign with my 3 and multiply them all together. Now what I'm going to do is I'm just going to take those numbers, multiply 7 times 7 times 3, and I'm going to get 147. This here is now complete. I just wanted to take it from a mixed radical to an entire radical. I don't have to simplify or anything like that. I'm doing exactly what it told me to do. Second one, 2 and the cube root of 4. My index is 3. My coefficient is 2, so I want to put 3 2's underneath my radical sign with my 4, multiply them all together, and you should get 32. Last example on this one here is 2 and the 5th root of 3. I now know I have an index of 5. I have 2 as my coefficient, so I want to put 5 2's underneath that radical sign with my 3, and I'm going to be left with, when I multiply it all together, 96. That concludes our lesson for today.